We're going to start solving systems of equations using substitution. You all know the substitution method, but we're going to actually be substituting in expressions for a variable, not just a number, into one of the other two equations we've been given. So let's look at some examples. This example, we're just going to kind of put all the answers or all the solutions here on the screen in just a minute, but for this one, we don't know what y actually equals. It doesn't have y equals 7 or y equals just 3. Y actually equals 3x. So it doesn't equal a solution, but it actually equals an expression. So what we're going to do, since we know what y equals, if I were to ask you what does y equal, hopefully you would tell me 3x. Since we know that 3x represents our y, then when we move to our second equation here, we have x plus y equals negative 32. Well, we know what y is. We know that 3x represents y. So instead of writing a y here, we could in fact make this a 3x. So we pretty much would just scratch out this y and put a 3x here. So that's what they've done here is step one. Since we know what y equals, we substitute it in. So in place of y, in our second equation here, we're going to put 3x. And then we just simplify. Y was 3x, so I replace the y with 3x. X plus 3x gives me 4x. 4x equals negative 32. I haven't done anything to the right-hand side here. And then you just simply divide both sides by 4. You solve this one-step equation and you get x is negative 8. And then after that, once you've gotten the value for x, in order to find our solution, because remember we've talked about we've got to have a point, an x and a y for our coordinate. Since you know that x is negative 8, you could actually plug that into either one of these x's. You pick the equation you want to plug it into and find the y value. Now, to make it easier on yourself, since you want to find y, and you know y equals 3x, this would be the easier equation to pick, and that's what they did here in step 2. They plugged negative 8 in place of the x for the first equation, and then just simply multiplied. 3 times negative 8 is negative 24. So the solution to this system is negative 8, negative 24. That's the x that you found in step 1 and the y that you found in step 2. So just when you know what a variable equals, then plug it into the other equation and simplify your expressions. Now, what you should do from there is check your answers. So take both of your equations separately and plug in negative 8, negative 24. And double check to make sure if you plug in negative 8, negative 24, it works for the first equation. And if you plug in negative 8 for x and negative 24 in for y, it does work in the second equation. Always good to check your solutions. So, now it's your turn. Here's your system of equations, and what's a little more difficult about this one for some people is that y equals 2x plus 7 and y equals x minus 1. You know what y is. It's two different expressions. Don't make this any more difficult than it really isn't actually. Don't make it difficult. Y equals 2x plus 7. Okay, so let's take this. Y is 2x plus 7. So this is what y, this represents y. So in place of this y, put 2x plus 7. Just replace this y here with 2x plus 7. So you are going to have x's on both sides of your equation here once you do that, but you should be able to solve that. I'm going to give you some answer choices to look at. You should pause the video, attempt this problem, see if you can solve this for x, and then once you find your x, plug it in and find your y. The solution that you should get for this, so if you don't want to know the solution, you might want to pause the video, but the solution that you should get is C. And then here is an explanation of how you would find that. Alright, so let's move on to example 2.
In this problem, you will solve for a variable and use substitution. What is the solution of the system? Use substitution. The first equation in the system is 3 times y plus 4 times x equals 14. The second equation is negative 2 times x plus y equals negative 3. What do you know? Neither equation is solved for one of the variables. What do you need? You need the solution of the system. So what's your plan? Solve one of the equations for one of the variables. Then use the substitution method to find the solution of the system. Step 1. Solve one of the equations for one of the variables. Which variable should you solve for? If one equation has a variable with a coefficient of 1 or -1, solve for that variable. It is generally easier to solve for a variable with a coefficient of 1 or -1. Write the second equation. Add 2 times x to each side. Simplify. For step 2, substitute 2 times x minus 3 for y in the other equation and solve for x. Write the first equation. Substitute 2 times x minus 3 for y. Use parentheses. Now use the distributive property. Simplify. Add 9 to each side. Divide each side by 10. Step 3. Substitute 2 3/10 for x in either equation and solve for y. Write either equation. Substitute 2 3/10 for x. Simplify. Add 4 6/10 to each side. The solution is the ordered pair 2 3/10, 1 6/10. Now it's your turn.
Okay, so just like she explained in that last example, you have two equations here and neither of them are solved for a variable. You don't have x equals something or y equals something. So basically what you do, what she did, is find the variable with a coefficient of 1 or -1 if possible, and then solve for that variable. Just like when we did literal equations and we had to solve for a specific variable, that's what you're doing here. Sometimes you solve for y, sometimes you may solve for x, but you want to get a variable by itself and then you can use the substitution method. Here's your answer choices, so be sure to pause the video and substitute in your values here and find your ordered pair, your x and y, and then determine A, B, C, or D. Obviously, if your answer does not appear there, then you need to go back and look at your substitution. The correct answer to this got it question is D. Of course, this is in fraction form, which you should leave this one in fraction form because of the type of decimal you get. And the solution to that you can see here. And you can read through there how they solve for the variable x for the second equation, and how the negative 7 minus 3y, they substituted that in for x. They solved that equation and found the value of y. And then they were able to simplify once they substituted in the value for y. They simplified down to what the value of x is. So be sure to look through that problem, make sure you know how to solve those.
In this problem, you will explore systems of equations with infinitely many solutions or no solution. Part A. How many solutions does the system have? The first equation is x equals negative 2 times y plus 4. The second is 2 times x plus 4 times y equals 8. How many solutions can a system of linear equations have? A system can have exactly one solution, infinitely many solutions, or no solution. Write the second equation. Substitute negative 2 times y plus 4 for x. Use parentheses. Next, use the distributive property. Simplify the left side of the equation. The equation 8 equals 8 is an identity, so the system has infinitely many solutions. The equations in the system represent the same line. Part B. How many solutions does the system have? The first equation is y equals 3 times x minus 11. The second is y minus 3 times x equals negative 13. Write the second equation. Substitute 3 times x minus 11 for y. Next, simplify the equation. The statement negative 11 equals negative 13 is false, so the system has no solution. The equations in the system represent parallel lines. Now it's your turn.
Okay, sorry about that, Belle. This is your got it question. First of all, these two are not solved for a variable, like the two examples she just did. So you're going to have to go back to what we did in example 2 and actually solve one of these equations for x or y, and then start plugging it in to determine what your system is. Now, here are your answer choices. Obviously, she said you can have 0, 1, or infinitely many, so automatically we should know that C is not correct. But solve this system, pause the video, solve this system, and determine which one of those is the correct answer. Now, your correct answer, hopefully you're finished, is D, infinitely many. And we can look at the solution here of how they solve for x for the first equation, plugged that value in for x in the second equation, and found that you do get an identity, you do get a true statement, therefore you have infinitely many solutions.